This lesson we're looking at seasonality, which is how much a variable changes due to seasonal factors. And then we also look at how to get rid of seasonality in our data by deseasonalizing the data. And if we do that, it'll let us make predictions more easily, see the trend more easily in our data. So looking at seasonal indices, in this example, we've got electricity usage in quarters. So we've got a couple of years and they're divided up into quarters. So in this graph, you can see the first 4 dots represent 1 year and the next 4 represent another year. And you can see the data is seasonal. There's a pattern for every year. You can see there's a pattern there and there's a pattern there. This is a seasonal data. And the first thing we're going to do is to find the seasonal index. So seasonal index tells us how much the data in that season, so it could be, in this case it's a quarter, is below or above the average of the entire data. So sort of think of the average of this data, and we're looking at how much of each quarter is below or above the average. So here's how we calculate the seasonal index. The first thing we do is we average out each year. So we add all of these together, divide by 4, and that will give us this value. And then we add all of these values, divide by 4. They'll give this as the average of this year. And then what you do after is that you take this data here, 244, and then you divide it by the average of the year. And they'll give you a number that is fairly small. It'll be always around 1-ish, depending on the data, but generally it'll be around that. And then you repeat this process for every data. So divide 260 by this average, 294 by the average, 360 by the average, so on and so on. And you repeat the process for the next year, which is this divided by the average, this divided by the average, so on and so on. And then you get all of these values. And then you take these values, and then you look at the data in terms of the quarters. So you look at quarter 1, and you add up these two values that you've got, and you average it out. So meaning divide by how many numbers you're adding. So in this case, we're adding 2. So we divide it by 2. So this is the process that we're doing. And then you have a seasonal index for that quarter. So average, 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 and it takes you to a seasonal index. So you end up with just the 4 values for each quarter. So each quarter will have a seasonal index. And then you can analyze what this means after that. So here we've got, for quarter 1, our seasonal index was 0.8485. And if you turn it into percentage, so that's just timesing it by 100, you get 84% as your seasonal index. So this means it's a little bit below the average. Average will be always at 100%. So it'll be below by that much. And the next quarter we have 91%, so it's below by around 9%. This one is a little bit over, so it's actually above the average by that much. The next one's a bit higher as well, so it's 20% above the average. And another reason why we care about this, and That's because we can use seasonality and deseasonalize a data. So we're removing the seasonality in our data. And the way to do it is to follow this formula. So in this formula, we've got deseasonalized figure, which equals original figure divided by the seasonal index. And as this is just a formula, if you were to find this or this, you can also use this formula, and you can use the CAS to find what those values are. So for example, if you had a value for this, let's say it was 100, and you had the value for the original figure, which let's say it's 70, but you didn't know the seasonal index, then you just put it as x, put it into the solve function, solve for x, and then it'll give you that value. Obviously, if you didn't know the original figure, but you need the seasonal index, then this will be the x. So you can obviously, as long as you have this formula with you and you don't know any one of these values, you can use the formula to find it. So this example here gives you the seasonal index for cold drink sales for summer right here. And then it gives you a figure, an actual figure of what the sales was for last summer. And then it's asking you for the deseasonalized sales. So taking seasonality out of this figure. And all you need to do is obviously put these values in the correct part of the formula, and it will give you the deseasonalized sales. So this next part here just talks about this formula again. So it's represented in a different way, but we're just using the same formula. So now the original figure, which is the actual figure, is our subject, and to find that we put them in this order. But again, this is the same as if you were to use this formula here and solving it on the CAS for the actual figure, it will give you the same outcome. So doing this, again, I would recommend using the CAS to do it. And again, all you need to find is where the values go, so seasonal index, and then this is the deseasonalized figure. So now you're finding the actual figure using these two. So all of this stuff that we did in this video comes together, and we use it to deseasonalize a data set, so we can look at the trend of the data easier, and it removes the seasonality from the data. So you can see even the actual sales in this graph had all these ups and downs, and it was seasonal. Therefore, when we deseasonalize the data, you can sort of see the trend is actually just like a slight increase over time. Now, when you have an actual data and you want to correct it for seasonality, so we are trying to figure out, well, how much of this data needs to be up here or down here for us to deseasonalize this data. Again, we can follow what we looked at before, and by using this, it will give you where your data has to end up after correcting it for seasonality. So depending on what you get out of this using this formula, if it's under 100%, you need to go down. If it's over 100%, you'll need to go up in your data.